Welcome to Math with Mr. J. In this video, I'm going to cover how to solve one-step inequalities and how to solve two-step inequalities. We will start by going through addition, subtraction, multiplication, and division one-step inequalities, and then move on to two-step inequalities. Now, when we solve inequalities, we want to isolate the variable, get it by itself on one side of the inequality. We do that by using inverse operations. So this is very similar to when we solve equations. One thing we need to be aware of, though, when it comes to inequalities, we flip the inequality symbol when multiplying or dividing both sides by a negative. And we will talk more about this later in the video. Let's jump into number 1, where we have w plus 7 is greater than or equal to 15. So we need to solve this. We need to isolate that variable of w. Now we are adding 7 to w, so we need the inverse operation of addition. The inverse operation of addition is subtraction. So let's subtract 7 from the left side of the inequality. Whatever we do to one side of an inequality, we must do to the other in order to keep it balanced. So subtract 7 from the right side as well. Now, as far as the left side, these 7s cancel each other out. W is now isolated, so we have w is greater than or equal to, and then on the right side, 15 minus 7 gives us 8. So we have w is greater than or equal to 8. So any value greater than or equal to 8 is a solution of this inequality. It makes it true. And let's check a solution to make sure we are correct here. Now we can't check every value greater than or equal to 8. That would be impossible. We have an infinite amount of possibilities as far as solutions, values that make this inequality true. So what we can do, we can check one value, or more if we would like, to see if this works. Let's use 10. 10 is greater than or equal to 8. So let's plug in 10 for w. So we have 10 plus 7 is greater than or equal to 15. 10 plus 7 gives us 17. 17 is greater than or equal to 15. So 10 does make this inequality true, along with any other number greater than or equal to 8. So we are correct here. Our answer for number 1, w is greater than or equal to 8. Let's move on to number 2, where we have x plus 4 is less than 9. So we need to isolate that variable of x. We are adding 4 to x, so we need the inverse operation of addition. That's subtraction. So subtract 4 from the left side. Whatever we do to one side, we have to do to the other. So subtract 4 from the right side as well. These 4s cancel each other out. X is now isolated, so we have x is less than, and then on the right side, 9 minus 4 gives us 5. So x is less than 5. So any value less than 5 is a solution of this inequality. It makes it true. Let's check one so we can pick any number less than 5. Let's use 3. So plug in 3 for x here. So we have 3 plus 4 is less than 9. 3 plus 4 gives us 7. 7 is less than 9, so we are correct here. Our answer for number 2, x is less than 5. So any value less than 5 will work for this inequality, will make this inequality true. So there's how to solve one-step addition inequalities. Let's move on to subtraction. So here are our subtraction examples. Let's jump into number 1, where we have y minus 2 is greater than 5. So we need to solve this. We need to isolate the variable of y. Now 2 is being subtracted from y. So we need the inverse operation of subtraction. The inverse operation of subtraction is addition. So add 2 to the left side of the inequality. Whatever we do to one side of an inequality, we must do to the other in order to keep it balanced, so add 2 to the right side as well. Now, as far as the left side, these 2's cancel each other out. So y is now isolated. We have y is greater than, and then on the right side, 5 plus 2 gives us 7. So y is greater than 7. And that's our answer. So any value greater than 7 is a solution of this inequality. It makes it true. And let's check a solution to make sure we are correct here. So we need to use any value greater than 7 here and plug it in for y. Let's use 12. So plug in 12. We have 12 minus 2 is greater than 5. 12 minus 2 gives us 10. 10 is greater than 5. So this does work. We are correct here. Our answer again for number 1, y is greater than 7. Let's move on to number 2, where we have -6 is less than or equal to c minus 3. So we are subtracting 3 from c here. We need the inverse operation of subtraction. That's addition, so add 3 to the right side of the inequality. That means we need to add 3 to the left side as well. Now, as far as the right side, these 3's cancel each other out. C is now isolated, so we have C is greater than or equal to, and then on the left side, -6 plus 3 gives us -3. So C is greater than or equal to -3. Now, one thing we can do here is rewrite the inequality with the variable coming first. It can make it easier to work with inequalities, so keep this in mind. And all we need to do is flip it. So we need our variable c, and then our symbol we need to make sure is going the correct way. So it's opening up towards c. We need c to be greater than or equal to -3. So again, we can rewrite this with the variable coming first if we prefer. Now let's check a solution. So we need any value greater than or equal to -3. Let's try 4. So we will plug in 4 for c. So we have 4 minus 3. 4 minus 3 gives us 1. And -6 is less than or equal to 1, so that does work. Our answer for number 2, C, is greater than or equal to -3. So C can be any value greater than or equal to -3. So there's our subtraction section. Let's move on to multiplication. Here are our multiplication examples. Let's jump into number 1, where we have 5x is less than or equal to 10. We need to isolate x. X is being multiplied by 5, so we need the inverse operation of multiplication. That's division. So divide the left side of the inequality by 5. Now, whatever we do to one side of an inequality, we must do to the other in order to keep it balanced. So divide the right side by 5 as well. Now, as far as the left side, these 5's cancel each other out. X is now isolated. So we have x is less than or equal to, and then on the right side, 10 divided by 5 gives us 2. X is less than or equal to 2. So any value less than or equal to 2 is a solution of this inequality. It makes it true. And let's check a solution to make sure we are correct here. Let's use 1. 1 is less than or equal to 2. So plug in 1 for x. So 5 times 1 is less than or equal to 10. 5 times 1 gives us 5. And 5 is less than or equal to 10. So we are correct here. Our answer, again, x is less than or equal to 2. Let's move on to number 2, where we have 36 is greater than negative 4a. So we need to isolate that variable of a. It's being multiplied by negative 4, so we need the inverse operation, division. So divide the right side by negative 4. That means we need to divide the left side by negative 4 as well. Now remember, when we multiply or divide both sides by a negative, the inequality symbol flips. So as soon as both sides are multiplied or divided by a negative, that symbol flips. And here we are dividing both sides by negative 4. As far as the right side, these negative 4s cancel each other out. So a is now isolated. We have a, and then the symbol flips, and then the left side, 36 divided by negative 4, gives us negative 9. So a is greater than negative 9. That's our answer. And we can rewrite this with the variable coming first if we would like. This can make it easier to work with an inequality. All we need to do is write the variable first. So a. Then we need to make sure the symbol is going the correct way. That's very important. It's opening up towards a here, so a needs to remain greater than negative 9. Either way is correct there, just something to keep in mind. Now, as far as flipping the inequality symbol, we're going to talk more about that and why we need to do that after we wrap up number 2. So again, our answer a is greater than negative 9. So a can be anything greater than negative 9. Now let's check a solution and let's use 0. So plug in 0 for a. We have 36 is greater than negative 4 times 0. Negative 4 times 0 gives us 0. And 36 is greater than 0, so we are correct here. A is greater than negative 9. Now, before we move on to division, let's take a look at flipping the inequality symbol and why this happens when we multiply or divide both sides by a negative. Let's take a look at flipping the inequality symbol and why this happens when we multiply or divide both sides by a negative. Let's start with the example 4 is less than 8. Is this inequality true? Of course, 4 is less than 8. Now let's divide both sides by positive 2 and see if this remains true. And let's rewrite this inequality so we have 4 is less than 8, and we are dividing both sides by 2. On the left, 4 divided by 2 gives us 2, and then on the right, 8 divided by 2 gives us 4. So we have 2 is less than 4. So does this inequality remain true? Yes. Now let's divide both sides by negative 2 and see what happens. And we will rewrite the inequality here. So we have 4, and then I'm not going to put the inequality symbol quite yet because we're dividing both sides by a negative, negative 2. And dividing both sides by a negative is going to change the inequality. So we have to flip the inequality symbol, change its direction for this to be true. So we have 4 divided by negative 2 is greater than 8 divided by negative 2. As soon as we divide both sides by a negative, that symbol flips. It changes direction. And that's because 4 divided by negative 2 is negative 2. And then 8 divided by negative 2 is negative 4. Negative 2 is greater than negative 4. So for that inequality to remain true, that symbol flips. So again, negative 2 is greater than negative 4. Now what if we did not flip that sign? Well, we would get negative 2 is less than negative 4. Is that true? No. So notice the difference between dividing by a positive 2 and a negative 2. Now let's apply this to number 2, the number 2 that we already solved. We have 36 is greater than negative 4a. So we need to isolate a by dividing both sides by negative 4. So let's rewrite this. And we have 36 divided by negative 4. And then since we are dividing both sides by a negative, the inequality symbol flips. And then we have negative 4a divided by negative 4. As far as the right side, these negative 4's cancel each other out. A is now isolated, so we have a is greater than, and then on the left side, 36 divided by negative 4 gives us negative 9. So a is greater than negative 9. Now, when we solved this before, we didn't rewrite everything. We divided both sides from the original problem. We flipped after dividing, and we ended up with the correct answer. And that was fine. But here I wanted to rewrite this to show that technically the symbol flips the moment both sides are multiplied or divided by a negative. So we wrote out that step to show that. Now, if you forget to flip the symbol, when you go to check a solution, you'll notice that it won't work. So it's important to check, and then you can catch that mistake. Again, just remember, flip the inequality symbol when multiplying or dividing both sides by a negative. So there's our multiplication section. Let's move on to division. Here are our division examples. Let's jump into number 1, where we have d divided by 10 is greater than 6. So we need to isolate that variable of d. It's being divided by 10, so we need the inverse operation of division. That's multiplication. So let's multiply the left side of the inequality by 10. Whatever we do to one side of an inequality, we must do to the other in order to keep it balanced. So multiply the right side by 10 as well. Now on the left side, these 10s cancel each other out. So d is now isolated. We have d is greater than, and then on the right side, 6 times 10 gives us 60. So we have d is greater than 60. So any value greater than 60 is a solution of this inequality. It makes it true. And let's check a solution to make sure we are correct here. Let's use 70. 70 is greater than 60, and we'll work with that 10. So let's plug in 70 for d. So we have 70 divided by 10 is greater than 6. 70 divided by 10 gives us 7, and 7 is greater than 6, so this does work. We are correct here. D is greater than 60. Let's move on to number 2, where we have x divided by negative 7 is less than or equal to negative 3. So let's isolate x. It's being divided by negative 7, so we need the inverse operation. That's going to be multiplication. So let's multiply the left side by negative 7. And that means we need to multiply the right side by negative 7. Now remember, when we multiply or divide both sides by a negative, the inequality symbol flips. So as soon as both sides are multiplied or divided by a negative, that symbol flips. And here we are multiplying both sides by negative 7. So as far as the left side, these negative 7's cancel each other out. X is now isolated. The inequality symbol has flipped, and then on the right side, negative 3 times negative 7 gives us positive 21. Remember, a negative times a negative equals a positive. So this is our answer. X is greater than or equal to 21. In other words, x can be anything greater than 21 or equal to 21. Now let's check a solution to make sure we are correct here. And let's use 28. That will work with the negative 7 since we are dividing here. So let's plug in 28 for x. So we have 28 divided by negative 7 is less than or equal to negative 3. 28 divided by negative 7 gives us negative 4. So we have negative 4 is less than or equal to negative 3. That is true, so we are correct here. Again, x is greater than or equal to 21. Now, before we end, let's take a look at flipping the inequality symbol and why this happens when we multiply both sides by a negative. This will be similar to what we looked at earlier in the video when we divided both sides by a negative. Let's take a look at flipping the inequality symbol and why this happens when we multiply both sides by a negative. Let's start with the example 2 is less than 5. Is this inequality true? Of course, 2 is less than 5. But let's see what happens when we multiply both sides by positive 2. Let's see if this remains true. And let's rewrite this with both sides being multiplied by 2. Now on the left, we have 2 times 2, which gives us 4. So we have 4 is less than, and then on the right, 5 times 2 gives us 10. So we have 4 is less than 10. So did the inequality remain true after multiplying both sides by 2, positive 2? Yes, 4 is less than 10. Now let's multiply both sides by negative 2. So let's rewrite this with both sides being multiplied by negative 2. But multiplying both sides by a negative changes the inequality. We have to flip the inequality symbol, change its direction. So we're multiplying the left side by negative 2, and then flip the inequality symbol, and then we're multiplying the right side by negative 2. As soon as both sides are multiplied or divided by a negative, that inequality symbol flips in order for the inequality to remain true. Because on the left, we are multiplying 2 by negative 2. That gives us negative 4. And negative 4 is greater than, and then on the right, we are multiplying 5 by negative 2. That gives us negative 10. Negative 4 is greater than negative 10. Now, what if that inequality symbol was not flipped? We would have negative 4 is less than negative 10. That inequality is not true. When we flipped the inequality symbol, that was true. Now let's apply this to number 2 that we already solved. We have x divided by negative 7 is less than or equal to negative 3. So we need to multiply both sides by negative 7. So let's rewrite this, and we are multiplying both sides by negative 7. And since we are multiplying both sides by a negative, the inequality symbol needs to flip. So that inequality symbol needs to change direction as soon as we multiply both sides by a negative in order for this to be true. Now on the left, these negative 7s cancel each other out. X is now isolated. So we have x is greater than or equal to, and then on the right, negative 3 times negative 7 gives us 21. So x is greater than or equal to 21. Now, when we solved this before, we didn't rewrite everything. We multiplied both sides from the original problem. We flipped after multiplying, and we ended up with the correct answer. But here, I wanted to rewrite this to show that technically, the symbol flips as soon as both sides are multiplied or divided by a negative. So we wrote out that step to show that. Like I mentioned earlier, if you forget to flip the inequality symbol, when you go to check a solution, you'll notice that it won't work. So it's important to check, and you can catch that mistake. So there's how to solve one-step inequalities. Let's move on to two-step inequalities. Now we're going to take a look at two-step inequalities. We will go through 4 examples in order to get this down. Now when we solve two-step inequalities, we want to isolate the variable, get it by itself on one side of the inequality. We do that by using inverse operations. So this is very similar to solving two-step equations. If you can solve an equation, you can solve an inequality. And just like what we talked about with one-step inequalities, remember, we flip the inequality symbol when multiplying or dividing both sides by a negative. Let's jump into number 1, where we have 7x minus 3 is greater than 18. Now here, just like with a two-step equation, we want to undo the subtraction first. We go in the reverse order of operations to undo the operations and isolate the variable. So we need to undo the subtraction first and then the multiplication here. The inverse operation of subtraction is addition, so add 3 to the left side of the inequality. Whatever we do to one side of an inequality, we must do to the other in order to keep it balanced. So add 3 to the right side as well. Now, as far as the left side, these 3's cancel each other out. So we have 7x is greater than, and then on the right side, 18 plus 3 gives us 21. So now we have 7x is greater than 21. 7 times x is greater than 21. So now we need to undo that multiplication using the inverse operation. That's division. So let's divide the left side by 7. That means we need to divide the right side by 7 as well. Now on the left side, these 7's cancel each other out. X is now isolated. So we have x is greater than, and then on the right side, 21 divided by 7 gives us 3. So we get x is greater than 3. And that's our answer. So x can be any value greater than 3. And lastly, let's check a value that's greater than 3 to make sure it works and we are correct. Let's use 5. So 7 times, plug in 5 for x, minus 3 is greater than 18. 7 times 5 gives us 35, and then 35 minus 3 gives us 32. 32 is greater than 18, so that does work. We are correct here. Again, our answer, x is greater than 3. Let's move on to number 2. Taking a look at number 2, we have y divided by negative 2 plus 5 is greater than or equal to 9. Now here, just like we talked about in number 1, we go in the reverse order of operations to undo the operations and isolate the variable. So we need to undo the addition first and then the division here. The inverse operation of addition is subtraction. So let's subtract 5 from the left side of the inequality. Whatever we do to one side of an inequality, we must do to the other in order to keep it balanced. So subtract 5 from the right side as well. Now on the left side, these 5's cancel each other out. So we have y divided by negative 2 is greater than or equal to, and then on the right, 9 minus 5 gives us 4. So now we have y divided by negative 2 is greater than or equal to 4. Now since y is being divided by negative 2, we need to undo that division using the inverse operation. That's multiplication. So let's multiply the left side by negative 2. Whatever we do to one side, we must do to the other, so multiply the right side by negative 2 as well. Now remember, when we multiply or divide both sides of an inequality by a negative, the inequality symbol flips. It changes direction. So on the left, these negative 2's cancel each other out. Y is now isolated. The inequality symbol flips, And then on the right, 4 times negative 2 gives us negative 8. So y is less than or equal to negative 8. So y can be any value less than or equal to negative 8. Now, as far as that inequality symbol flipping, basically, as soon as we multiplied both sides by a negative, negative 2 for this example, that inequality symbol flips in order to keep the inequality true. Lastly, let's check this by plugging in a value that is less than or equal to negative 8 for y and seeing if it works. So we can see if we are correct here. Let's use negative 10. That's less than negative 8. And since we are dividing by negative 2, that will work nicely there. Then we have plus 5 is greater than or equal to 9. Negative 10 divided by negative 2 gives us 5. And then 5 plus 5 gives us 10. 10 is greater than or equal to 9. So that does work. We are correct here. Y is less than or equal to negative 8. And then since y can be equal to negative 8, let's try that as well. And we will do this mentally. So we have negative 8 divided by negative 2 plus 5. Negative 8 divided by negative 2 gives us 4. 4 plus 5 gives us 9. And 9 is greater than or equal to 9. So that works as well. Let's move on to number 3. Now let's take a look at number 3, where we have negative 4n plus 6 is greater than or equal to negative 14. So we need to undo the addition first here. We use the inverse operation, which is subtraction. So subtract 6 from the left side. That means we need to subtract 6 from the right side as well. Now these 6's cancel each other out. So we have negative 4n is greater than or equal to, and then negative 14 minus 6 gives us negative 20. So now we have negative 4n is greater than or equal to negative 20. So now we need to undo that multiplication. The inverse operation is division. So divide the left side by negative 4. That means we need to divide the right side by negative 4 as well. Now you'll notice that we're dividing both sides by a negative, so that inequality symbol flips. Now on the left, these negative 4's cancel each other out, so n is now isolated. Then the inequality symbol flips, and then negative 20 divided by negative 4 gives us 5, positive 5. So n is less than or equal to 5. And that's our answer. So n can be any value less than or equal to 5. Now let's check this by plugging in a value less than 5 for n and seeing if it works. Let's use 2. So we have negative 4 times 2, plug in 2 for n, plus 6 is greater than or equal to negative 14. Negative 4 times 2 gives us negative 8. And negative 8 plus 6 gives us negative 2. Negative 2 is greater than or equal to negative 14. So we are correct here. N is less than or equal to 5. And let's actually check 5 as well, since n can be equal to 5. And we will do this mentally. So we have negative 4 times 5. That gives us negative 20, plus 6 gives us negative 14. And negative 14 is greater than or equal to negative 14. So that works as well. Let's move on to number 4. Lastly, let's take a look at number 4. We have 3 is greater than m divided by 9 minus 8. So let's undo that subtraction first by using the inverse operation, addition. So let's add 8 to the right side, and then we need to add 8 to the left side. Now on the right side, These cancel each other out. So we have m divided by 9 is less than, and then on the left side, 3 plus 8 gives us 11. So we have m divided by 9 is less than 11. So we need to undo that division. The inverse operation is multiplication. So multiply the right side by 9. That means we need to multiply the left side by 9 as well. These 9s cancel each other out. M is now isolated. So m is less than, and then on the left, 11 times 9 gives us 99. So m is less than 99. And remember, we can always rewrite an inequality with the variable coming first. It can make an inequality easier to work with. And all we need to do is write the variable first and then make sure the inequality symbol is going the correct way. So it needs to open up towards 99 here. M needs to remain less than 99. So m is less than 99. Either way works there, but keep in mind you can rewrite it with the variable coming first. Now let's plug in a value for m that is less than 99 to see if it works. Let's use 90. Since we are dividing, that will work nicely with that 9. And 90 is less than 99. So 90 divided by 9 minus 8. 90 divided by 9 gives us 10. 10 minus 8 gives us 2. And 3 is greater than 2. So that does work out. We are correct here. Again, our final answer, m is less than 99. So m can be any value less than 99. So there you have it. There's how to solve one-step and two-step inequalities. I hope that helped. Thanks so much for watching. Until next time, peace.